Okay, I think it's time to talk about star garnets a little bit today, where if you've seen my previous video from almost a year ago now, I talked about how to best cut into potential star garnets to try and find, where the star might be. It's my most popular video by far, and there's quite a few comments on there that are both helpful and not very helpful. Some of them have been trying to suggest, what you do, and one of the suggestions was to make a sphere out of the star garnets and essentially cut in from the outside, make it all the way round and polished, and then that way you can see where the stars are, and then from there you cut into it and use that to line up where to make the star. And I thought that seemed like a lot of work to make a whole sphere out of these and then do the work from there, which I guess if these are really precious, then, maybe you need to do that work in order to preserve as much material as you can. I thought I would do a little test to see, just how many of these star garnets would actually star from the Emerald Creek locality in Idaho. And what I did was went to the local lapidary workshop, Mike's shop, and I think I ended up with about 12 star garnets that I selected based on, they have good crystal faces or they were big, basically. What I've heard from a couple sources is the bigger they are, the more likely they are to star. And there are a couple of forms of garnets where there's the ideal, dodecahedron, where you got the 12 crystal faces that are, if the crystal is whole, they look really nice. But there's also a kind of crystal varieties that are more twinned and might have 24 sides rather than 12. And I read from one source that these are less likely to star. And so I cut a couple of those. My initial results were not very promising. These are the cut faces that I actually worked with. These are the off cuts. So some of them are too thin to do anything with or really busted. Some of them I might be able to actually work with in the future and maybe get a star on the other side, so you get 2 stars for the price of 1 stone, which is nice. And my initial test was to cab them down, do a light dome shape, and from there ground it on a 60 grit wheel and then ground the kind of rough edges off with a 600 grit wheel. And from there I didn't see any stars, which was really disappointing, especially when a lot of these have what I would think to be our more characteristic patterns on the inside. In some of these, there's a hexagonal twinning that you can see from the cut face that would suggest that there was growth zoning and, silky inclusions in there, which I thought would be able to star, and yet I wasn't seeing any stars on my 600 grit polished cabs, or half cabs, I guess. They're not very domed. And in order to get a good star, you actually need a relatively high dome, higher than a normal cabochon. And that was disappointing. I thought, okay, well, none of these star. That's the result, they're not going to star they're not guaranteed to star from that area. It wasn't until we kind of got a little frustrated and went further with the polishing where I took it to a 325 grit wheel to kind of get rid of these more flat areas on the stones from the 600 grit. Because the 600 grit only gets rid of the really coarse scratches from the 60 grit wheel. It's kind of a odd process, but it works really well for cabbing. So we took it to a 325 wheel, and obviously that was less polished than the 600 grit, so you didn't see anything there. But then we jumped up to a 1200 grit wheel, and after we did that, we were able to see stars. And this is one of the bigger samples and shows a star really well. I think the results from that suggest that you need to get up to at least a 1200 grit in order to see a potential star in the stones. And after I did that, I realized I wasn't going to be able to take all of the stones that I cut up to 1200 grit, so I had to kind of pare back a little bit and chose some of the better samples. These ones were offcuts, and this one fell apart as I was cutting. One of these is that 24-sided crystal, and all of these have at least a little bit of asterism in them, which is the star. The smallest one yielded a pretty poor star, which makes sense from what I've heard. This one I was a little bit off center. The star kind of crosses over in this face on this side here, so it's a little bit off center, but it's a decent star for the size. And this one despite its size, is fairly weak. And that may be because I'm too close to the edge, didn't have a high dome. It's kind of purpley in the middle, which I've taken to be a sign that it's not a great star potential. I think the darker the stone on the interior, the better it is. Because if we look at this one that had a good star, where some of the twinning planes are, which I think are hard to see here, but it's obvious on other samples, the star isn't as well defined or disappears completely, and it's kind of a, dashed line pattern of a star. Another thing I've concluded from this is that the ones with the raisin pattern on the outside, it's kind of hard to describe, but this is a well-formed crystal on my left hand, and on the right hand it's pitted. There's some weird pattern marks on the outside. This is the raisin appearance. It's the best description I've been able to find of it. And these ones are almost wholly black on the inside and yield really nice stars. But you can see that flashing across there. And I actually left this one not very well polished because the way the ray goes across the stone on this face here, it actually lights up almost the whole thing in one go, which I thought was pretty cool. And if I wanted to try to locate the star, it seems to be somewhere in the peak of the stone there, where the sun is, flashing mostly. And similarly, these are the stones that my wife found from the area. She found, I think, 2, maybe there's a third one in there that's kind of small, but these are the only couple of potential raisin skin stones that we found. And besides the outer appearance, these stones are also noticeably heavier than the well-formed crystals. And so if you find one that feels relatively heavy for its size, that one's more likely to star up as well. But I think what's interesting about this site is that I found estimates of, 10% of these will star, or, all of them should star, or 50% will star. And it probably depends on where within the locality they were getting those garnets from in the first place, because the Forest Service digs up from different parts of the creek and brings that material into the dig site. And I think we had a pretty good locality. From what I heard, these are pretty good size for the area in that Forest Creek site, at least. From my results, at least if you get up to 1200 grit, you're likely to see at least a little bit of asterism in every stone that I looked at. Now, that's not going to say that every single stone should be a star garnet, because there are stones like the ones that I faceted in previous videos. Those ones were relatively clear and wouldn't have as much silk, and so probably wouldn't star. But I think by and large, you will get some asterism in the garnets. Now, it doesn't mean that these will all make good star garnets. Obviously, these ones are pretty fractured. There's still some polishing powder on the inside of these cracks here that are going to be almost impossible to get out. Some of them, fell apart as I tried to cut them, just because they're so fractured. Like, I didn't go very far with this one because on the other side, it's just a mess of fractures, and if I cut down too far, I'm going to get into that, and it's just going to look terrible. So if you want a good star garnet cabochon, I think you need to look for the raisin skin appearance and the heavier garnets. But it is also, I would say, the larger the stone, it's worth cutting, because you're going to get at least a little bit of a star. If that's all you have, then, I think it's worth it to get a nice star out of it. And one of the other comments I got on the video was that, oh, you just need to take one of these stones and cut it parallel to the C-axis, and that's where you get your asterism. Well, in garnets, the axes, the A, B, and C axes, which are related to how the crystal grows and the faces that it forms, those are all equant, where the C-axis is maybe a little longer than the other ones. The A and B are more equal, and then it's maybe slightly elongated in one direction versus the other two. You can see it's a little more blocky in that face, or in this orientation. So this might be the C-axis. Okay, so then you got to cut it parallel to that axis down the middle and cab it up. But then what if you have a piece like this one where you only have a a fractured piece with maybe a face there and there, but it's kind of eroded away. What do you do for that, you know? Do you cab it up from the outside and see where it is? Those are the questions that I wanted to answer in that video and then in the follow-up with this one. Lastly, I mentioned it kind of, but a lot of these are very fractured. And one thing you can do, which I didn't do in this case, I did in my previous video, but before I started cutting them and looking at them closely, I dipped them in muriatic acid overnight to clean out the iron clay material and the mica as well. And that really cleaned out the cracks a lot. And you can see a lot better into the stones, how far some of these cracks go, and you're able to tell, you know, this stone might not be good if these cracks go, you know, all the way through and crisscross, especially with something like this, where in some cases that kind of cement material may be the only thing holding some of these pieces together, which I found in my previous video was that some of them fell apart as I got rid of that matrix material. So in conclusion, if you want to make a star garnet from the Emerald Creek localities, look for the raisin skin, look for heavy stones relative to their size compared to other stones of similar size. And you need to polish them at least to 1200 grit, I think, in my experience. Maybe someone else can see them at a less highly polished state, at 600 or something if you do a really good job. But I was going quick. These are just a rough and ready, you know, cabs just to see if they did star at all. I'm not really into cabs, so I didn't really care about making them perfect. But, you know, we got some stars, even from some of the smaller ones. Not that one. Even from these very small ones, you can get a little bit of a star, which is pretty cool. And this face that lights up with the light really kind of gives me an idea of maybe you can facet a star garnet where the facet falls on that plane of asterism, and you can make sort of a really interesting pattern with it. I don't know how you would do that, but I'll look into that and see if I can do anything with it. So until next time, keep looking to the stars.